Simplifying rational expressions. How is simplifying rational expressions similar to simplifying fractions? Well, let's think about a fraction such as 10/15. Now, when we look at fractions like this, we think about what number goes into these numbers. And if we can, in a way, we would think about them as what are the factors of these numbers. So for 10, we'd have 5 and 2, and for 15, we'd have 5 and 3. And then we know that any number of itself is equal to 1. That allows us to cancel and then simplify the fraction all the way down. We're going to use this concept with a rational expression. So we have to remember that a rational number is any number that can be made into a fraction. So that's a basic definition. If we take that a step further to rational expressions, now we're looking at a fraction that has two polynomials. This could be something as simple as x plus 2 divided by x minus 3. We have two polynomials, they're in fraction form, and we're going to still look at it from the same view of simplifying, reducing fractions. That's how we're going to reduce these rational expressions. So, a couple things to think in mind. We have to think, are there any values that need to be excluded when we think about rational expressions? Well, first of all, we have to know about excluded values in fractions. We know that with fractions, we don't want any denominator to equal 0. If this does occur, we know that this is undefined. And because this is undefinable, we don't want that to occur in our rational expression either. So those are going to be what we call excluded values. So if we were to look at something like this, x plus 2 divided by x, we can say x could be any number except that x cannot equal 0. Because again, we cannot have 0 in the denominator. Here we have x divided by x minus 2. And in this case, to keep the x from going to 0, we would say that x cannot equal 2 because 2 minus 2 would equal 0. So as long as we stay away from the numbers that cause our denominators to go to 0, that will enable us to define all the numbers that make this possible. So how will we simplify them? Let's kind of get a plan here. And our plan is going to be we're going to factor out our common factors. We're going to cancel and simplify. And the way we're going to cancel and simplify is we're going to do it by three areas: by constants, by variables, and binomials. And again, some reminders. Constants are just numbers by themselves, like 3, 5, -2. Variables, by definition, are letters of the alphabet. And binomials are two-term polynomials. So we're going to take a look for these types of things, and that's how we're going to cancel. So let's watch a demonstration here. I have 3x minus 12 divided by x squared minus x minus 12. Well, first thing I would do is factor out in the numerator the 3, which would give us 3 times x minus 4. In the denominator, we have a trinomial, x squared minus x minus 12, and we would use the diamond method to regroup and give us two binomials of x plus 3 and x minus 4. We can see that these binomials are exactly alike, so we're going to cross them out because that's going to give us our big giant 1. And then what is left is 3 over x plus 3. Now, a lot of people want to grab those 3's and cancel those 3's, but I'm here to tell you. And we can't. And why is that? Well, we have to understand this 3 up here is a constant. Down here, this x plus 3 is a binomial. They're two different things. And because they're two different things, we cannot cancel them. So we want to keep that straight in our mind, what we can cancel. Constants with constants, variables with variables, binomials with binomials. Another way to think about this is that this is an addition sign, this is a division sign. Division and addition are not related, so you can't really cut across that line. Here we're multiplying 3 times this, x plus 3 times this. Because they're multiplying, we can cancel across the division line because multiplication and division are inverses of each other. So that might be another way to think about it. Okay, let's do some examples together. Here we have 36x squared divided by 2x. So again, we're going to deal with our numbers first, our constants. So we're going to divide both the 36 and the 2 by 2. We do that and we get 18 in our numerator and we get 1 in our denominator. Then we take a look at our exponents. And here we have x squared in the numerator, x in the denominator. So if we remember our exponent rules, we keep the base, and because we're dividing, we subtract the exponents. Well, that's going to give me x to the first power. Well, that x to the first power is going to stay up here in the numerator. Another way to think about that is if you've forgotten your exponent rules, you can think that you have 2 x's in the numerator, 1 x in the denominator, one set's going to cancel. There'll be one left over in the numerator. So we're at this point here, and then we're just going to simplify to 18x. That's a breakdown of how this works. So let's try another one. 5x divided by 40x to the third. Once again, we're going to take those constants and, in this case, divide by 5. 5 divided by 5 is 1, and 40 divided by 5 is 8. We take a look at our variables. We have a base of x and 1 minus 3. Well, 1 minus 3 is equal to x to the negative 2, and we know x to the negative 2 is 1 over x squared. So we're going to drop our x squared there. So our final answer then is 1 over 8x squared. Again, if you can't remember your exponent rules, think about 1x on top, 3x is on the bottom, one set cancels out, there's 2 extra on the bottom. Let's take a look and start throwing in some binomials. Here we have 15 minus 5x. We're going to factor out a 5, leaving behind 3 minus x, and in the denominator we're going to have 5x. Once again, we got to remember we're multiplying this constant times this binomial, this constant times this variable. Because of that, we can see 5 divided by 5. We know that's a big giant 1. Then we're left with 3 minus x all divided by x. Once again, we cannot grab those x's because the numerator is a binomial, it's protected. 3 minus x, this is a variable by itself. So this is as simple as it gets. Here we have 5x plus 3 divided by x plus 3. 5x plus 3 is fully factored. It might be considered a prime binomial. There's nothing we can pull out of it. There are no common factors. Same thing with x plus 3. Now they may look alike and you might think there's a 5 left over, but in reality they are different binomials. Because they are different binomials, we're already going to say that this is already simplified. So we want to keep our eyes open and looking for something like that. Don't feel that every problem means that there must be something that you have to do, because you don't have to do it all the time. You've got to think about it. What will you do and how will you do it? Here we have a trinomial x squared minus 3x minus 10 divided by a binomial x minus 5. Well, let's use the diamond method to regroup that numerator. So this will be negative 10 and negative 3 with a negative 5 and a positive 2. So let's regroup x squared minus 5x plus 2x minus 10. We're going to cut it in half and pull out the greatest common factor, which is x, leaving behind x minus 5. Writing that common factor on the other side, and we'd see we'd multiply this side by 2 to get back to 2x minus 10. Pulling out the common factor of x minus 5 leaves behind x plus 2. So we're going to rewrite that numerator as x minus 5 times x plus 2. We're going to divide it by the denominator, which happens to be x minus 5. And we can see that we have alike binomials, so we'll cancel those binomials out. And it leaves us with just the binomial of x plus 2, and that would be this rational expression simplified. And one more we're going to take a look at. Here we have x squared minus 6x plus 9 divided by 9 minus x squared. We're going to do the same thing with the numerator we just did with the other one a second ago. We're going to regroup. So a positive 9 and negative 6. So that'll be a negative 3 and a negative 3. So let's rewrite x squared minus 3x plus 9. We're going to cut it in half and pull out the greatest common factor, which is x, leaving behind x minus 3. Then we're going to multiply this times negative 3 to get back to this original binomial, and pull out the common binomial, which is x minus 3, leaving behind x minus 3. So we know that this numerator is going to factor into x minus 3 times x minus 3. Now our denominator, we see, has only 2 terms, so we have to remember our factoring. This is difference of squares. So this is going to factor down to 3 minus x and 3 plus x. You've got to remember your patterns. Now when looking at this, we see here that these are both positive, and here we have one positive, one negative. We have one positive and one negative one on top as well, but they're opposite. Here we have a negative 3, here we have a positive 3. In the numerator positive x, denominator negative x. So what we need to do is factor out a negative 1 so we can do some canceling. So let's change this x minus 3 into negative 1 times negative x plus 3. If we factor out that negative 1, now we have alike binomials, and these two binomials now can cancel out. That leaves behind for us negative 1 times x minus 3 all divided by 3 plus x. You can leave it as a fully factored form like this. I'm usually very acceptable of this, but sometimes in textbooks we find that they multiply that negative 1 back out. When they do, you're going to get negative x plus 3, and let's use the commutative property on the denominator and call that x plus 3, and that way we can see how they're different. So hopefully this will help you in simplifying rational expressions.